Welcome, everybody. We are almost done with 2/3 through the class. I hope you had a good, not winter, summer. Well, I hope you had a good winter break too, but I hope you had a good spring break. Whoa, that's loud. Today, obviously, we're going to be reviewing. In case you did not hear, there is a midterm next class, and I would love it if you would all get A's. Last time, the most common grade, well over half the class got A's and B's. I would love to push that up. Please remember, I gave an incentive to say, what did I say? I said if y'all raise the average, I will give a bump to the grade. I will curve up the last exam. It depends on how much the average raises, but impress me, and I will reward your work. We got a lot of equations. There are a butt ton of equations in this module. You have to be able to know what applies when. What equation does it make sense to plug into? So I'd like to do a bit of that. I'd like to give you a scenario, give you some numbers, and just ask, what formula should I apply this to? I would like to do a little bit of plug in, but even more than that, just being able to identify what makes sense, what is applicable to a given situation, and what is extraneous information, I think is super important. I would also love it if I get particular suggestions, requests from the crowd. You have, if you want to ask me something, I will give you what you need. I'm also, by the way, willing to hold extra office hours this week, this Wednesday. Oh, for God's sake, the MCAT review session on Wednesday is canceled, and I'm going to hold an extra office hour at that time. That's Wednesday at 10, as well as answer questions if you send them early, questions on the Discord or via email. I think that's everything that you need to know about administration. Do I have any questions about administration before we get into specifics? Okay, you all know you can have an equation sheet. You have to buy the Scantron, blah, blah, blah. Great. 25 questions is what I'm writing this time. Yeah. Okay, let's dive in. Find the capacitance of a cloud of a lightning cloud, of a lightning cloud. You can, we don't say lightning cloud, thundercloud. Of a storm cloud that is releasing a bolt of lightning. I will tell you. I will tell you about the lightning that is released when it arcs. I will give you the area of the cloud's surface. Oh, no. A cloud is one plate. The other plate is the Earth. The Earth underneath the cloud and the cloud itself form effectively a big fat capacitor. So I will give you the surface area of the cloud. I will give you the voltage on the cloud. And I will emphasize, by the way, 1.5 billion volts is pretty honkin' big. I will give you the... I also want you to find capacitance and charge, by the way. The distance, the height of the cloud is what? About a kilometer? Great. Find the charge in the cloud, and this is the word and, not plus. Doesn't make sense to do that. And the capacitance. I can't words today. It's okay. A professor doesn't need to be able to talk. Let's put this in the Google form too, and I didn't clear the Google form. So give me a second. This way I can see where you're at and what you're struggling with. Tell me the charge in the cloud and the capacitance for the cloud. Is good? You know what you're doing? Start by identifying what equation applies, then plug in numbers. Nope, nope, no, no, I haven't cleared the form yet. Half a second, half a second. 0316, save the data. There we go. You may now record responses in the form. I will remind you that both a coulomb and a farad are very large units. And if you are getting billions upon billions of either, check your math because you goofing. That looks stupid. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27, 28. When I get 28 responses, I will answer. Gesundheit. Is good? Good. Okay, please pay attention to the order I asked. I did say it backwards at first, but if it's on the screen as first tell me charge, then tell me capacitance, you should do what I have down. One more minute. No, that was mistakenly included. I did not pull that from last year. I was hoping to get through that in the slides. I will give free credit for those problems in the homework. Those slipped through cracks. How do you do physics? No, it's still absolutely a mixture of concept and idea. Concept and calc. Hold on. Nope. Nope. Midterms are. Nope. Nope. I'm just telling you I'm pulling that. Okay, I'm going to call that time's up. How I see an easy way to do this, a straightforward way to do this, is actually to start with the second term. I recognize in my equations, first off, what kind of scenario am I even talking about here? What is this? Is this points or is this capacitors? How do you know it's capacitors? Because I freaking said capacitor and I ask you for capacitance. It is not uncommon for students, watch out for this in the stress of the test or whatever, to completely glaze over the freaking hint that is given in the problem statement and apply the wrong formula. If you read the question, it very often tells you what kind of scenario you've got here. So the correct answer here is we are going to use the capacitor formulas. And the very first formula we got with capacitance, once we defined it, is A epsilon naught over D. Hey, I've got A, I've got D, epsilon naught's a constant. That would be provided to you. I just plug in. So if I plug in, A is 10
Please take some time for yourself.
1 times 10 to the 5 meters squared. Epsilon naught, this would be printed on the test. And distance there is 1.2 kilometers. Plug this into your calculator, and if I recall correctly, the capacitance I get is about 73 picofarads. Or you could also express that in scientific notation any way you want. 7.3 10 to the minus 11 is also perfectly correct. 70. I rounded. I rounded incorrectly, but I rounded. Okay, so once you've got the capacitance, there is a simple single formula that connects capacitance and voltage to charge. Were you able to identify the defining equation for capacitance? Capacitance is the ratio of charge to voltage. Well, I could just plug in. Solve, plug in. 1/9 of a coulomb-ish. Okay, please check your powers. I had a whole bunch of people pick the correct equation and were off by a factor of 10. Off by a factor of 100. Check your powers real fast. Where'd you goof? Which term did you make a mistake in plugging in? That's perfectly acceptable. That's perfectly acceptable. 1.110 to the minus 1? Oh, right. It follows on the previous error. Yeah. Okay. Okay, I challenge you. Now let's talk about what formulas you could even apply. Google question C. What else could you find immediately without any other information? Give me an equation that applies in this scenario that you could find immediately. Any equation. Or equations. Actually, I could think of two. What did you get for capacitance? 7.3 10 to the what? That is incorrect. Should be 7.3 10 to the minus 11. If I am not greatly mistaken. It's not 100,000, it's 10,000. Yeah.
It was the comma he had initially there.
Yeah, I put the comma in the wrong place because I need to go back to third grade. Okay, let's see what you guys put. Okay, several people are giving me the equations that I just applied. And those are true statements, but I'm asking for what equations also apply here. What other equations could you use in this circumstance that are not only true equations, but applicable equations? What other terms could you find? I'll give you another minute. Not things that you already know that I just used. I am very pleased. I am seeing a lot of people use the correct form of the energy equation. Molto bene. Okay, here's what I immediately knee-jerk reaction get when I see these equations. I got volts. Come on, draw. I got volts, I've got meters. This leads me immediately to the electric field equation, volts per meter. Well, I should write this as, if I've been given volts and meters, I can jump immediately. Oh, hey, the relationship between voltage and distance gives me electric field. Well, I think of it as the relationship between voltage and electric field involves distance. I've got two of the three variables. Another equation that I've got, I've got charge. Well, I get charge, I get voltage. I jump immediately to energy is 1/2 charge times voltage. Remember, it's not energy equals charge times voltage for the total in a capacitor. For an individual charge sitting in some voltage, QV. For a whole capacitor, all of the energy stored in it, half QV. By the way, my apologies again. An equation that I had thought we would get to and then didn't yesterweek in class, the energy density equation. I did not remove it from the homework after we did not hit it in lecture. That's actually, let's hit it real fast because it is not nearly as hard as it looks and it gives you a practice. Since we did not cover it in the main section of the class, since it was not supposed to be on the homework, this particular exact equation ain't on there. But don't zone out. You need to know the individual puzzle pieces that go into this. This will help you practice them. We have found the total amount of energy in this. I am going to challenge you to write this in a different form using some of the other formulas that we've got. For instance, I would like you to write this in terms of electric field, hint, hint, instead of voltage. Can I apply electric field instead of voltage here? Do so. Google question D. Write the total energy stored in the capacitor in terms of the electric field and stuff. Capacitor, he says. Oh, there's a question. Oh, okay. Pranavi, that's okay. Hint, hint, hint. We just did this. It's right there. I'm asking you to replace the voltage term with an electric field term. Gesundheit. One more time, I'm asking for potential energy on the left, not electric field. Please solve for potential energy in terms of. I am not asking for a number. I'm asking you, can you simply solve this equation? Can you substitute in to eliminate voltage and get electric field? Okay, I think that's all the correct answers we're going to get. If I've got the relationship between electric field and voltage, and I want electric field instead of voltage, I can solve this equation for voltage and shove them in. That's the idea of algebra. So if you don't know a variable, you could replace them with something that's equal to. So I wanted energy. The next question is I want you to interpret what do each of these letters mean? Do you know them? What does the term refer to? And is it a known quantity? So let's break this up into individual pieces. Google question E, what does Q represent? F, do we know it? Yes or no? G, what does E represent? H, do we know it? I, J, same thing with delta x. So look back over what we've done and identify meanings for these terms. No, Pranavi, I don't want you to say the value. I want you to say yes or no. Do we know it? Have we calculated it? I don't want a number. I just want yes or no. Could you find the number? Is the number written down somewhere? Is the number in the room with you right now? And please be specific about what does each thing represent. For instance, if I were talking about just be specific and tell me not just a single word for EGI. Tell me the blank of what? Last semester, we talked about force a butt ton. Don't just say F is force, say F is the force that the ball exerts on the bat. So give me details about the Q of what, the E of what, the delta X of what. Again, you can look back over what we just did to identify these terms. Okay, one more minute. Okay, that was less than a minute, but I want to move on. Q represents the charge stored in the cloud and ground. Charge stored in the capacitor would also be acceptable. Stored. Yes, we just discovered it right there, 0.11 coulombs. What does electric field represent? Electric field, what does E represent? Between earth and ground. Cloud and ground. Do we know it? Well, I just wrote down the equation for it, but we did not solve for it yet. We did not evaluate that number yet, but I've got an expression for it. What does delta X represent? Here is the trickiest one. Delta X represents the distance. Where? Exactly. Here's where physics is different than a math class. Often in a math class, you've got X and you've got Y, and who cares about the difference between them? They're just letters. In physics class, everything has a meaning. And if you don't interpret the meaning of this, if you let it be alphabet soup, you're screwed. So you have to be able to interpret this. So the distance here, delta X in this equation, electric field times distance, the electric field times distance where? The distance along the field direction. Remember where field and voltage were connected, energy and force. Which direction is the energy changing? Same direction the force pushes it, not sideways. Voltage is changing from cloud to ground, so that's the relevant distance here. What does delta X represent? Yes, it was given. It's the 1 kilometer value. Now, the slightly wonky part here that you might not expect, switching to electric field, okay, yeah, whatever, slightly wonky version term here, is I would like you to write down the electric field between the plates of a capacitor and solve for charge. Can you do that? Can you do that? Write down the formula, just the formula, for the charge on a capacitor in terms of its electric field. Do not give me the charge on the capacitor in terms of the capacitance. Do not give me the charge on the charge on the plates in terms of the voltage. I want an expression with Q on the left side and something involving E on the right side. This is Google question K. Identify your variables and use the correct formula. You may actually have to read the formulas and interpret them before you can find something that could be solved for this. Look for a formula involving Q and E and solve for Q, baby. Good. Yes is not correct. Good. Good. Incorrect. You should solve for Q on the left and something involving E on the right. And it should apply to capacitors. So many right answers. Several people not listening to directions. Hints on the board that I said. I'm seeing a lot of correct answers, but about half of you aren't listening to directions. Okay, getting it wrong, sure, okay, whatever. Not answering the question at all is, don't do that. Grr. You must find an equation connecting charge and electric field in a capacitor and solve that equation for charge. If your equation involves voltage, that's not the right equation. If you're telling me about resistance, that's not the right equation. If the left-hand side of your equation starts with E equals, that's not the right equation. You have not solved for the correct variable. Please check to make sure that all three of these conditions are satisfied, and then resubmit. Still in Google question K. If you already have done this, congratulations. I'm not talking to you, only the other half. Much better. Not perfect, but much better. Hey, think for a second. Hey, not just knowing what's right, but why what's wrong is wrong. Why is it wrong? What is incorrect about saying solving KQ on R squared? KQ on R squared is a true equation. Why doesn't it work here? Turn to your neighbor and discuss real fast. Why isn't KQ on R squared the right equation to use? Solving E equals KQ on R squared. The correct answer is E equals KQ on R squared is not true in capacitors. It is the electric field near what? Near a point charge, a distance r away from a point charge q. Why is it incorrect to say electric field times capacitance times distance? Oh, well, no, actually that does satisfy all the conditions that I asked. Never mind, that's a true statement. I would like you to substitute in capacitance in there, the student who told me ECX. Okay, so the equation that I was pleased to see that many people got correct is the electric field inside a capacitor is the charge on that capacitor divided by area times epsilon naught, which can be solved for Q as follows. So far, so good. What does this represent? Charge on what? Charge in the capacitor, charge on the cloud, and for the charge on the ground. What's A represent? The area of what? Of the cloud, of the capacitor plate, if you will. What does E represent? Electric field in the region between them. Good. Okay, now I want you to plug this equation into the previous equation, and I want you to tell me the total energy divided by the total volume between the capacitor plates. This is called energy density. And I'd like you to tell me it numerically. You can give me that as a number. Plug the one formula into the other. We're going to get something you ain't never seen before. But you, if you've passed high school geometry, should be able to express this in terms of volume and tell me energy divided by volume. I will remind you, if you don't remember the constants, and I will remind you that the previous expression was naughty, naughty. So my challenge for you is Do you remember what volume is? Cubic meters? Length times width times height? Cross section times height? Pi r squared h? Deja vu? Okay. And I would like you to solve again. Please read the question. Now, you know what? I'm not going to tell you what I want you to solve for. I want you to read the question and ask yourself, am I solving for the variable that the instructor asked for? Variables. Correct. Mostly correct. Good. Oh, you specified units too. Molto bene. Very good. Okay, it looks like we need some help. Not everyone, but getting there. What I'm asking you to do is first to find the energy, the total energy, in the terms that we have been pushing together. And then I'm asking you to find the total energy and divide it by the volume of the capacitor. I will remind you that volume ain't nothing but area times distance perpendicular to that area, AD. So if I take the formula, energy equals 1/2 charges AE epsilon naught, and I multiply that by ED, I am taking an equation, I am taking a term and replacing it. I don't know Q, I'm replacing it with something that is equal to something I know. This is energy. Can you solve this for energy density, energy divided by volume? You should be able to. Then plug in numbers. And you can solve for the other variables in terms of what we just gave and the equations that we just wrote down. Hint, hint. Nope. I'm not seeing any more people popping up. Okay. So I can simplify this equation. If I'm multiplying all these numbers together, E times E goes by the name E squared. I identify, as I just said, area times distance between as the volume. Let me put that there so people don't get it confused with the voltage. Volume times electric field squared times epsilon naught is the total amount of energy. I asked you in here to find the energy divided by the volume. We have just discovered an equation for the total amount of energy. The energy has volume in it. What happens if I divide both sides by volume? The energy per volume, the energy, the joules per cubic meter, pew pew. Now, you want a number? Well, earlier I gave you the equation that electric field is volts per meter, and I gave you the voltage, and I gave you the meters. You can substitute these values in and get E. I gave you epsilon naught. You should be able to plug in known values to a formula and get the answer. Please, in Google question L, give me not the equation, but show me that you can evaluate this for a number. I've given you a new formula. Can you plug in? Please make sure when you type in 1.5 million, you are squaring all of the terms in 1.5 times 10 to the 6. See, a fair number of people are simply squaring the 10 to the 6. It's not what E squared means. No, no. Okay, so I've written the algebraic expression, I've written the numerical expression, and I've still only got a handful of people plugging this into your calculator, right? That's not okay. It's not okay. You have to be able to multiply and divide numbers. There are a couple of things that could be going screwy here. Let me test to the variables. I am going to give you a BS equation. I'm going to check to see if it's actually plugging in and multiplying and dividing numbers, or if this particular problem, being multiple steps, is somehow interfering. I'm going to tell you that quantity x equals 3 times, no, I'm going to say 3 times voltage over distance squared times epsilon naught. I will remind you the values that we got. Google question M is evaluate X. We'll go into tips and tricks if we have to, but I'd like it if I'm wrong. Ooh, that's big. Good, good, bad, good, bad, good, good, bad, good, 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 bad.
This. But would have been.
Mm-mm. Yeah,
With this.
show me the previous.
And I went in and put
What's Q?
punch.
What'd you get for Q? That's right. Okay.
So then,
Yeah, okay.
so then that
What'd you get for
divided by-
area?
It was given.
Oh, good.
So
And when you,
8.85 times 10 to the 12.
okay, and when you
So
plug
that's
that
when
in,
I got that. So maybe this is
show me in your calculator how you plug that in.
because once I did it the other way, like
I know what you did. You got 10 to the minus 9. You didn't put parentheses around your downstairs.
I'm gonna check it. But I'm like,
I'm almost certain that's what you did. When you divide two terms, you must put parentheses around them. Okay, I've got correct answers trickling in. Uh, uh, Hold on a second. A is 5, B is 12, C is 13. Please tell me what is A squared plus B squared divided by... Nope, no, 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 I'm going to make it the other way around. C over A squared plus B squared. Testing whether scientific notation is screwing you over. I'm getting more correct answers for the previous part. And we're going to move on after this. So far, so all of them right. Most of them right. Okay, what is that? 90% correct. Okay, let me encourage you. If you did not get 0.077, 0.08, please come to my office hours. This doesn't have to be as hard as it is. Struggling for no reason here. You can learn this fast and everything gets easier with that. If you did get 0.077, good. I'm going to come back to where the calculator skills are dying. I suspect that you guys are dying with the scientific, not all of you, again, a third of you are dying due to scientific notation problems. I want to come back to this. I'm not going to spend all pre-lecture trying to work out calculator mistakes. I'll review. Okay, so a big part of what I've seen so far, of what I'm encouraging you to do is to be able to identify the correct equation, to be able to plug numbers in, identify what terms mean. So far, I'm seeing mostly good with this. Another muy importante skill that you must have is to be able to reason about, does this double or halve this? We have started to tangle with this. We're going to tangle with this even more. Does this change that? Does this affect that even the slightest bit? If this changes that, by what factor does it change that? So we did a couple of these problems yesterday class. We've sprinkled these throughout. I want to make sure that you've got this here. I want to test a hypothesis here on your brains. I want to start by giving a couple of expressions with X's and Y's. Okay, so example, Google question O. If Y equals 2 over X, and I double X, how does Y change? By what factor does Y change? What do I multiply by to get the new? And Google question P is if I double Z, yes, I know what I'm writing. Sorry? If I double X, yes, Y equals, let me emphasize, this is a dose, 2, 2, da da da. 2 over X, not Z over X there. You guys can write a ratio instead of words, by the way. What is the ratio of two quantities? Everyone can express this as a number. You don't have to write words for either of these. You can write a number for both of these. And the number is, when I talk about a ratio, what I'm saying is, what is new value divided by old value? What do I multiply by to get the new thing? What is the factor that I multiply by? So I want two numbers. Not words, please. Numbers. Please listen to directions. Okay, so I've got 20 people who are getting the first one right, and like 3 people who are getting the second one right, and I think this might be part of why some of the circuit stuff was so hard. If I have the expression 2 divided by x, and I have y old equals 2 divided by x, and I have y new equals 2 divided by x, has x changed? Have I changed x? No. I have doubled z. Doubling z is not the same thing as doubling x. Doubling z is doubling z. If I form the ratio now of these two things, this is not 0, and this is not 4. You could simplify a fraction with a fraction by multiplying by the denominator of the denominator, which is to say x over x, which is to say 2 over 2. This is the same number as 1, rumor has it. I want to emphasize here, just because you see a change does not mean that this changes that. You have to reason about, well, does this actually affect quantity x, quantity y? Let me give you an example in the context of this problem and see if what I just said has clicked for anybody, or for everybody, hopefully. The charge on a capacitor doubles. How does its capacitance change? Let me ask, by what factor? What is the ratio? What is the capacitance new divided by the capacitance old? Please don't tell me words. You can tell me a ratio in terms of numbers, or precisely one number. And please refer to what I just said about the previous problem. Hint, hint. Furthermore, I'm going to refer you to the formula. Okay. Good. What is the meme? Is the Q in the room with you now? Doubling charge, does that change area? Doubling distance between the plates, does that change the area? Epsilon naught is a constant of nature. If the physical properties of the capacitor ain't changing, does the capacitance change? Niet. No. 9. Da, 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 da. No. Now, we have a formula that says capacitance is charge per voltage. Let me ask you this. If charge doubles, what can we deduce? Google question R. I am leading you up to a realization here, I hope. Here, you may write words. I'm not asking for a number. I'm right asking for a short phrase or sentence. Good. First answer, correcto. Correcto. Incorrecto. Please refer to what I just said. Hmm. 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 Concrete example. Better, but not where I want you. You're missing the point. Not all of you. I'm getting a lot of people who are getting this. I have a salary. I'm hourly. I'm hourly. Pretend I'm hourly. I make $15 an hour. Okay? That increases every year that I've been at ASU. I used to make $3 an hour, and they kept me in a cage underneath CLCC. And every year I've earned a little bit more money. If I work twice as many hours, how does my rate change? How does my dollars per hour change? I'm doubling the number of hours I work. My rate increases based on the number of years I have worked. My rate is equal to some function involving only the number of years I have worked. 3 plus 12x, 12t. Yes. No, it's not the defining equation, but it is an always true equation for the parallel plate capacitor. If you have two equations that hold involving lots of variables, and one of the sets of equations, the variables aren't changing, then you know that that quantity is not changing, the other variables change. But look, let me go to my real world example. Let me go to my real world example for a second, because I am making a point that I will ask about on Wednesday at least once, and I would love it if the people who are paying attention are this lesson, this is not as hard as y'all are making it. Some are making it. Too many are making it. My hourly rate, my hourly wages depends only on my years worked. This week, I work twice as many hours. I will remind you, by the way, that the wage rate equals your dollars per hour. What can you deduce? No. What happens to my rate? What happens to my hourly rate? Think about the real world circumstance, about if you work more hours. Yes. So far, every single person who is answering has got the idea. If hours double, what happens to rate? Okay. We've got 90% here. I'll take it. The answer here is that your wage rate, I don't suddenly get 30 bucks an hour. It's not like ASU appreciates me anymore just because I worked more hours. I get twice as much money. My paycheck increases. That doesn't mean that I am suddenly a 30-year veteran of ASU that earns $30 an hour. That's capacitance. Capacitance is a ratio between two quantities. Charge affects voltage, voltage affects charge. You have an equation C equals Q over V with three variables, and about a third of you are insisting that every variable affects every other variable. You have to think about, no, the capacitance of a capacitor is set. It is fixed by the capacitor. There is a formula for how much capacitance a capacitor has, A epsilon over D. If those don't change, C can't change. So in the formula Q over V, and you already know that C doesn't change, changing V doesn't still magically change C. You know C doesn't change. C changes V. Please meditate upon this fact. We are out of time. You are welcome to ask me additional questions. I'm adding an additional office hour on Wednesday at 10 or via email. I love you. Good luck in your studies. Yes, I will post it right now. I will do my darndest to get this recorded.